Hello. Now today we are going to discuss about the surface area and volume exercise 13.2. A solid is in the shape of cone standing on hemisphere with both their radii being equal to 1 centimeter and height of the cone is equal to its radius. Find the volume of the solid. Now, first of all, what we have to do, we have to draw a diagram, and after diagram, all the dimensions we have to write. This is the first step to solve this type of problem. Now, if you will see, this is the cone which is mounted on the hemisphere. Now hemisphere radius is given 1 centimeter. If this is 1 centimeter, then depth is also 1 centimeter, and this radius is 1 centimeter, and cone height is 1 centimeter, and radius is 1 centimeter. So all the values are given. So we had written radius of the cone, height of the cone. So required volume of the solid is nothing but the combination of the volume of the cone plus combination of the volume of hemisphere. So both structure we have to include the volume of both the structure. So first of all, you have to command on the formula, and once you will write the formula accurately, then you have to only substitute the value. So volume of the cone is 1 by 3 pi r square h, and volume of hemisphere is 2 by 3 pi r cube. So radius, and after that, what is the major technique to solve? You have to take the common. Here the values are very small, so directly if we will substitute 1 by 3 pi r square into h, all the value are 1, and here 1 cube. So this is pi by 3, and this is 2 by 3 pi, and this is pi centimeter cube. So always remember, unit is very, very important. Now next, Rachel, an engineering student, was asked to make a model shape like a cylinder with two cones attached at its two ends by using a thin aluminum sheet. The diameter of the model is 3 centimeter and length is 12 centimeters. So this is the diameter it is given of the model. If each cone has the height 2 centimeter, then find the volume of air content in the, so we have to find out the volume of the particular model. So first of all, we have to draw a diagram. Now this is the required diagram. So total length of the diagram is given 12 centimeter. First of all, write the length, and after that, this is the cone, and this is another cone, and this is the cylinder. So first of all the value we have to write. Now BC is equal to ED equal to 3 centimeter. This is given. So whatever the model that student prepared, model is the combination of cylinder and two cones. So volume of the air will be equal to the sum of volume of two cones and one cylinder. So all the structure value we have to write down. BC equal to this value is equal to DE. This value is 3 centimeters. So radius is 1.5 centimeter. Height is 2 centimeter. This height is 2 centimeter. So the value of AF is 12 centimeter. It is given 12 centimeter. Now length of the cylinder is, this is 2 centimeter and this is 2 centimeter. So this 2 centimeter it will go. So we have to subtract from 12 centimeter. This become H2 equal to height equal to 8 centimeter. So total volume of inside the model is volume of the cone plus cylinder plus cone. So 2 times this and this volume are same, and this volume. So 2 times of the volume of the cone plus volume of the cylinder. So 1 by 3 pi r square h1 pi r square h2 1 by 3 pi r square h1. So from this we have to take the common value, and 1 by 3 pi r square is the common. So h1 plus 3h2 plus h1. So just we have to substitute all the value and do the calculation, and after doing the calculation it is coming 66 centimeter cube. Next, a gulab jamun contains sugar syrup up to about 30% of its volume. One particular gulab jamun contains 30% of syrup. It contains 30% of its volume. Find approximately how much syrup would be found in 45 gulab jamuns, each shaped like a cylinder with two hemisphere ends with the diameter is given, length is given 5 centimeter and diameter 2.8 centimeter. So first of all, we have to draw the diagram. So where this is cylinder and this is two hemisphere. So in this, the total length is 5 centimeter and this is given 2.8 centimeter. So according to this, if we will calculate the length of the AB, so this length is nothing but the 2.2 centimeter, because this is 1.4 centimeter and this is 1.4 centimeter. Similarly, this is 1.4 centimeter. So 1.4 plus 1.4, that is 2.8, and if we will subtract from the 5, then this becomes 2.2 centimeter. So that's why the length of this cylinder is 2.2 centimeter, and radius of the sphere in this hemisphere and this hemisphere is 1.4 centimeter. Now, after that, height of the cylinder already we find out. Now, volume of the gulab jamun is 2 into volume of the hemispherical part plus volume of the cylindrical part, because this two hemisphere is there. So 2 times 2 by 3 pi r cube plus pi r square h. So this is 4 by 3 pi r cube plus pi r square h. Pi r square, once we will take the common, then always take the common and then try to solve for, then and always do the calculation at the end. 4r by 3 plus h. So all the value we have to write, and at the end we have to find out the volume of one gulab jamun is 9394 divided by 375. So volume of 45 gulab jamun, just we have to multiply by 45 in this one gulab jamun volume, then we will get this volume. Since one gulab jamun contains syrup 30% of its volume, so for the 45 gulab jamun, just we have to multiply by 30%, that is 30 by 100, and this is giving 338 centimeter cube. So this is the quantity of the syrup found in 45 gulab jamun. Now, question number 4 we are going to see. Question number 4: a fan stand made of wood is in the shape of cuboid with 4 conical depression to hold pens. So this is the structure is given. One is cuboid whose dimension is 15, 10 and 3.5 centimeter. This is the dimension of the cuboid. Now, radius of each of the depression is 0.5 centimeter. This is the radius. It is looking here. It is the radius, and depth is 1.4 centimeter. Find the volume of wood in the entire stand. We have to find out the volume. So the most important thing, first of all, we have to find out the volume of the cuboid. So volume of the cuboid is LBH. This is the formula, and all the dimension is given LBH. So this is 525 centimeter cube. Now, radius of one cone, that is nothing but the conical structure. Conical depression is 0.5 centimeter and depth is 1.4 centimeter. So one conical depth volume is 1 by 3 pi r square h. And there are total 4 volumes there are 4 holes are there, which is in the conical shape. So once we will draw the diagram of this is 0.5 centimeter, height is 1.4 centimeter. It is given. So volume of one conical depression is 1 by 3 pi 22 by 7. Radius is 0.5 and height is 1.4. So this is the volume of one conical depression. So for the 4, then we have to just multiply in this by 4. Then we got 22 by 15 centimeter cube. Now, this 4 holes just we have to subtract from the volume of the cuboid. Then we will get the volume of the wood in the entire stand. So volume of the cuboid, that we got it, and volume of the 4 conical depressions, just we have to subtract 22 by 15. It will give 525.53 centimeter cube. Now, question number 5. A vessel is in the form of inverted cone. Its height is 8 centimeter. Now, according to the given data, this is the structure. The cone height is 8 centimeter and radius is 5 centimeter. It is filled with water up to the brim. This is the water. It is filled up to the brim. When lead salts, each of which is a sphere of radius 0.5 centimeter, are dropped into the vessel, 1/4 of the water flow out. Find the number of lead salt dropped into the vessel. Now, in this type of question, what we have to do? First of all, we have to find out the total volume of the cone. That means volume of water filled in the vessel. First of all, we have to find out. Now, in this, there are two structures: cone and spherical lead salts are given. Lead salts are dropped into the vessel, so lead salts flow out the water from the vessel equal to its volume. Height is given. Radius of the vessel is given. Now, volume of water is equal to the volume of cone. That is 1/3 pi r square h. This is the volume of the cone. Now, volume of the cone we will write. Now, pi is 22/7. Radius is given 5 centimeter. So 5 into 5. Height is 8. This height is 8. So according to the given data, just put the value and we got the volume of the cone. Now, radius of spherical leads are 0.5 centimeter. So volume of one spherical salt is 4/3 pi r cube. Now, in this, for one lead salts, we find out the volume of lead salts. Now, let n be the number of lead salts dropped in the vessel. Then, according to the question, we have to find out the number of lead salts. So n into volume of one spherical lead salt is equal to, now 1/4 of the water flow out, 1/4 of the volume of water filled it in the vessel that came out, that is equal to the volume of one spherical lead into n. So from here, n into 11/21, that is the volume of this, and volume of water filled it into 1/4. So after calculation, we got n equal to 100. So this is the number of lead salts is 100. Now in the question number 6, a solid iron pole consists of cylinder of height 220 centimeter. Height is given 220 centimeter and base of the diameter is given 24 centimeter, which is surmounted by another cylinder of height 60 centimeter and 8 centimeter. Now, height and diameter of the one cylinder as well as height and diameter radius of the another cylinder is given. So, if we want to draw the diagram of this, so this is the diagram. First cylinder is 220 centimeter and this is the pole which is the diameter of 24 centimeter. Another is 60 centimeter and diameter is 16 centimeter. Now, 8 centimeter radius, that is diameter is 16 centimeter. We have to find out the mass of pole. Total mass, what is the total mass? Now it is given that 1 centimeter cube of iron has approximately 8 gram mass. Now, so first of all, this unit, first of all, we see, this is 1 centimeter cube. This is 1 centimeter cube. This is nothing but the volume. So if we will find out the total volume of both the cylinder and if we will multiply by this, whatever the gram is given, then we will get the total mass of the pole. So first of all, height of the first cylinder is 220 centimeter. Now this is given 224, that is radius is 12 centimeter. Now height of the second cylinder H2 equal to 60 centimeter and radius. So total volume of the iron pole is volume of first cylinder plus volume of second cylinder. So from here, for the calculation point of view, pi r1 square h1 pi r2 square h2. Pi is common, r1 square h1 r2 square h2. Now 3.14, radius 144 into 220 height, and this r2 square, that is 64, this is 12 square and this is 8 square. So this is the value. After calculation, we got this is the total volume of the pole. Now it is given 1 centimeter cube of iron pole has mass 8 gram. This is 1000 actually. 1 gram equal to 1/1000 kg. So this is nothing but the 1 centimeter cube. This is the mass of 1 centimeter cube. So total volume is this. Just we have to multiply this two value. Okay. So if we will multiply this two value, then we will get the total value of the mass. This is the total kg. This is in the kg format. Now in the question number 7, a solid consisting of right circular cone of height 120 centimeter and radius 60 centimeter standing on hemisphere of radius 60 centimeter is placed up right in a right circular cylinder full of water such that it touches the bottom. Find the volume of water left in the cylinder if the radius of cylinder is 60 and height is 180 centimeter. Now, first of all, see the diagram. This is the cylinder. Now, in this cylinder, this is the cone and this is the hemisphere. Now, first of all, what we have to do, we have to find out the volume of the cylinder, and volume of the cylinder is nothing but the total water that is filled in the cylinder. After that, we have to find out the solid volume of the solid, that is the combination of the cone and hemisphere. After that, how much water actually flow out due to putting this solid inside the cylinder. So first of all, we have to subtract from the volume of the cylinder minus volume of both the combination of the solid. So we will see, this is the basic concept. Now solid is the combination of cone and hemisphere, and it is placed inside the right circular cylinder, and height of the cylinder is 180 centimeter, that we converted into the meter, that is 1.8 meter. So this is the first value that we converted into the meter. Now after that, radius of cylinder is, this is given 60 centimeter. This is 60. So this is 0.6. So volume of water filled in right circular cylinder, that is pi r square h. Pi is 22/7. R is 0.6 into height 1.8. So this is the total volume of the cylinder. Now, for the conical portion, if you will see, height of the cone is 120 and radius is 60. So first we converted that in the same unit, meter. For hemisphere, this is the 60 centimeter is the radius. Now total volume of the solid is volume of the cone plus volume of the hemisphere. So volume of the cone is 1/3 pi r square h, that is pi r1 square h1, and 2/3 pi r cube. So this is the volume of the cone and hemisphere. So just by substituting all the value, we got the value. Here radius is 0.6 square, height is 1.2, and here 0.6 whole cube. Now first of all, whatever the common value, that is 22/21, 22/21, this value and this value we take out, and 0.6 whole square, this is the common value. First we take out, and this is the value. After calculation, we got, this is the total volume of the solid. Now putting the solid into cylinder, the volume of water flow out from the cylinder will be equal to the volume of solid. So volume of water left in the cylinder is nothing but the total volume of water filled in the right circular cylinder minus volume of solid. So both the values just we subtract, and we got this total. This is the volume. So whatever the things we explained, this we had written. Now question number 8. A spherical glass vessel has cylindrical neck 8 centimeter long. Generally we see in the lab this type of structure. 2 centimeter in diameter, 2 centimeter diameter. Diameter of a spherical part is 8.5 centimeter. This is 8.5 centimeter diameter. By measuring the amount of water it holds, a child finds its volume to be 345 centimeter cube. This is the total volume. Check whether C is correct, taking the above as the inside measurement, pi equal to this. Now, given a spherical glass vessel is combination of a sphere as its has base and cylinder. This is the two structure. Now for the cylindrical portion, if you will see, for the cylindrical portion, this is the cylindrical portion. If you will see, then height is equal to 8 centimeter. This is the height. Now radius is, this is the diameter, radius is 1 centimeter. So for the spherical portion, radius is, this is the diameter, so radius is 8.5 divided by 2. Now volume of water filled in a spherical glass is volume of cylinder plus volume of sphere. So just we have to substitute the value. We know the value pi r square h1 4/3 pi r cube. So just we have to substitute the value and we got this is the correct answer. So I hope this is crystal clear for all of you. Just you do some practice and command on this exercise. Thank you.